And welcome to the first chapter in Algebra on Arithmetic Progression, or as the short form is called AP. So we'll begin with a little introduction and we'll look at a scenario which I'll keep coming back to over the course of this chapter to help introduce certain concepts and problem solving techniques to you. So the scene is as follows. You're in class and your professor, out of the blue, all of a sudden makes this announcement. Examination next week. Now the first thing that would happen, your stress levels would go into the red zone. But apart from this, examinations also tend to have a very beneficial side effect. And that is that people tend to study harder and harder as the exams come closer. So let's take a look at what a graph of someone studying for an exam in the week before an exam would look like. Okay, so someone is studying for an exam and we are going to look at their study pattern in the 7 days right before the exam. So this is the graph. The days before leading up to the exam are on the x-axis. The number of hours that they study are on the y-axis. So on the first day of the week, they don't study much. Okay. On the second day, they study a little more. On the third day, they study some more. On the fourth day, still some more. And so on. And finally, on the seventh day, they study the maximum. Okay. So I'm going to leave this graph right here for the present. We'll come back to it later. Before we move further with the chapter, we need to get some advice from this old philosopher, this very famous great philosopher called Aristotle. And Aristotle made a very useful statement. He said, first, let us define our terms. This is extremely important when we are having any kind of discussion, because if we do not define our terms, then it is very likely to lead us to confusion and misunderstandings. So at the outset, we need to define what we are talking about. So in the context of arithmetic progressions, let's begin with definitions. So for arithmetic progression, there are three things that we need to be familiar with, three concepts that we need to define, and they are a set, a sequence, and a progression. Begin with a set. Now what do we mean by a set? A set is a collection of distinct elements. Now I've highlighted the word distinct in red because it's a key word of the definition, and what it means is that in a set you cannot repeat elements. So you cannot have the same element listed twice in a set. Every element has to be listed only once, meaning all the elements of a set have to be different. So it is a collection of distinct elements and they can be arranged in any order. So the order of the elements in a set does not matter. So a set consisting of 1, 2, 3 is the same as a set consisting of 3, 2, 1 or 2, 3, 1 or 2, 1, 3 or whatever. So the order that the elements are arranged in does not matter in a set. So now we come to our next definition. That's going to be a sequence. So a sequence is also a collection of elements. Now notice that we've omitted the word distinct as compared to the definition of a set. So in a sequence, you can repeat elements. You can have the same element listed more than once. It doesn't matter. Whereas in a set, you can list an element only once. So a sequence is a collection of elements, but they have to be arranged in a definite order according to some rule. So this is another difference compared to the set. In a set, the arrangement of elements can be in any order, it doesn't matter. But in a sequence, the elements have to be arranged in a definite order according to some rule. Now finally we come to a third definition, and that's a progression. So a progression is a special type of a sequence. So a progression is a sequence with the same relationship between any two consecutive terms, meaning any two terms which are together, which go one after the other. So any two consecutive terms will have the same relationship. Then you will call that sequence a progression. So progression is a special type of sequence in which any two consecutive terms have the same relationship, okay, with the same relationship between any two consecutive terms. So now that we've defined what a progression is, let's go a step further and talk about an arithmetic progression, which happens to be the title of our chapter. So an arithmetic progression is a special type of progression. Remember, I said a progression is a special type of sequence, and an arithmetic progression is a special type of progression. So an arithmetic progression is also a sequence, but in this case, the relationship is a difference. So it is a sequence with the same difference between any two consecutive terms. What does that mean? It means that if you take any two terms which are together, which come one after the other, and you subtract one from the other, you will always end up with the same difference. Okay? Then you call that sequence an arithmetic progression.